Hey students, so yesterday we considered the idea of graphing sine waves. There was quite a bit of information that we discussed yesterday. So before we do today's examples, I want to take 1 minute just to recap and re-highlight some of the things that we discussed yesterday. Just real quick guys, don't copy, just watch, don't copy, just watch. Yesterday I mentioned something about 3 dotted lines. Let me elaborate more upon that very quickly. So let's say that I wanted to graph something like this on here. This number 2 is always going to be the middle line. I went through 2 because that's 2. If this was negative, I would have gone there. So whatever number this is your midline. Now from here, I am going to go up and I am going to go down. How much in both directions? This much. Don't worry about the negative for now. So from here, go up 6. Okay. 1, 2, 3, 4, 5, 6. Go back to the middle. Now go down 6. 1, 2, 3, 4, 5, 6. So that quickly, you can draw your 3 lines, where this is the middle, boom, and then you go up and down this. Does this graph, does it go up and down, or does it go down and then up? Well, because the value of a is negative, we can expect that the graph of this would be something that goes down and then up. So given that this a is negative, we can expect something that has this orientation, where the graph would go down, and then it would come back up, and then it would stop. So now let's go back outside. So yesterday I gave you an equation, and you gave me the picture. Today I gave you the picture, and you give me the equation. Provide the equation of the given sine graph. So let's go something like this, and then something like that. Now I'll give you this point here, and I'll give you this point there, and I'll give you this point here. That the start point is located at negative pi sixths, comma, negative 1. I'll tell you the end point is at 5 pi over 6, comma, negative 1. And that random point up there, this random point is going to be at pi twelfths, comma 2. So this is the given information, and it's our job to return to them the equation that goes with this graph. It reads y equals a times the sine of b times x minus h close plus k. So we have to find a, b, h, and k, drop them into their corresponding slots, and we're done. Now of those 4 parameters, which one's the easiest to identify? I would recommend that we first try to find k. And it's not that bad because k is always going to be the midline. You don't have to do this, but it's not a bad idea. Draw your middle line, which looks like this. Draw your high line, which runs like that, and then draw the low line, which runs something like this. If you want, you could put the low point here, the middle point there. Yes, this is the 1, 2, 3, 4. This is the 5-point method. We don't need all 5 points. I drew them just for fun. Look at the y coordinates of the points that are on the midline. They are located at negative 1. So just like that, you know that k is negative 1. The next component that I would go for is A. A is the amplitude, and that means from the middle, how high do I go up, or how high do I go down? From the middle. So let's go to the middle. Here, I'm going to go up because I have no information about this point, but I have plenty of info here. So from the middle, how much did you have to rise up to reach this level? Well, you're going from negative 1 all the way up to 2. So that is a movement of 3 units. So for that reason, A is 3. However, is A positive or is it negative? Given that we went up first and then down, you know that this is positive. If the graph had gone down and then up, this would have been negative. Up next, I would go off and find the value of h. H here is the phase shift. It is essentially the x-coordinate of your start point, given that our start point is at negative pi sixths. Boom, just like that, you know what the h is. All that's left to find is b, and we're done. Now before that, a quick FYI. Folks, we know that sine waves are repetitive. It's the same cycle going over and over and over again. So from here to here, that is one period. And then after this period, you have the next period, which goes from there to there. And then from here to there, and so on and so forth. From here to there, the amount of time that this takes, the amount of time that this takes, the amount of time that each of these, that's called the period. So now we understand what a period is, but how do we find it as a number? Well, we were given a formula for that. So the formula that we were given yesterday was period equals 2 pi over the absolute value of b, but I'm just going to write b because for us b is always going to be positive. Now, consider a more logical approach to this. Think of, for instance, period number 1, which begins at 7:30 and goes to 8:24. What happens if I go 8:24 minus 7:30? You know what I get in return? I get 54 minutes. And you know what? That is the length and duration of a period, 54 minutes. How did I discover that? I wrote down the end minus the start. So the end minus the start, that equals the period. So this gives us a different approach to finding the period for a sine wave. You could just go the end x-coordinate minus the start x-coordinate, which can then be set equal to 2 pi over b if you substitute it into there. So let's make sense of this together. Let's go back outside. The definition of the period is 2 pi over the absolute value of b. But we also know that a different way of finding the period is to go the end minus the start. Now, when I say end minus start, I am referring to the x-coordinates. So let's see what that gives us. So doing my work down here, so this is period equals the end x-coordinate is 5 pi over 6 minus the start x is negative pi over 6. Now we know that the double negative becomes positive. So this plus this, crunch that into your devices, you actually get back just pi. So pi is the period. So you can take pi, which is the period, and plug it in into the left-hand side. That'll tell us that the period pi equals 2 pi over the absolute value of b. Let's solve this equation for b. We'll drop it in here, and we're done. So let's see. So to solve this equation, maybe you can drop a 1 down there. Maybe I can cross multiply so that 2 pi equals pi times the absolute value of b. So we just cross multiplied. 1 times 2 pi is 2 pi. Pi times this is that. I can divide both sides by pi. It'll essentially knock this out with this. So we have the absolute value of b equals 2. So really, b is just going to be 2. b, for the most part, is always going to be positive. Just keep that in mind. So we have just found that b has a value of 2. So final answer, y equals 3 times the sine of 2 times x plus pi over 6 plus, because of that double negative, yes, that double negative, close this, minus 1. So this here is the equation associated with this graph. If you were unsure, you could always type this into Desmos along with the domain from yesterday, and it should look pretty much just like this. So now it's your turn. Please try the attached exit ticket, and we'll play more tomorrow.